Because the last person I had to take it was 9th period. So, alright, here we go. Alright, hey, I do want these back. Don't throw them away, don't crumble them up. I am going to collect these, but at least you get to see them. You have 1 week from today if you're going to choose to retake. 1 week from today.
Oh my god! This is the best grade I've ever got in my life.
100%?
100%. Oh yes!
But we just put it in my calculator. Take it out of my calculator. And then take my phone, put it under my phone. My legs as a group.
Oh, what'd you got on the right? So, half. Make number right.
You know,
Josie. Just hand it to one. Yep. And you really never found that.
is that mine? I don't want this grade.
Alright, here we go.
Thanks, Nicole.
Oh no.
Hey, I'm gonna click the lights. We're gonna go through this here in a second. Okay, ready? 16. Alright.
We have to sit like this.
Yeah. Oh, you're fine. Turn it down. Okay. So, okay, it's out of 70s. The big thing is, if you're going to choose to retake, you always have that option. It has to be done, completed, finished by next Monday. The reason why I think the end of the quarter is in a couple weeks. I want to make sure that it's done, completed, that you're not waiting too long to retake. If you are going to choose to retake, you have to stop in at some point this week, before or after school, because I don't have basketball, so you can anytime you want. We'll start reviewing. You don't need to email me. You don't need to tell me. You just stop in. We'll review the problems you missed. If you have not stopped in by next Monday, I'm assuming you're not taking it. Because by next Monday, that should be the last day that you scheduled to retake. So that means you, at some point this week, you have to just come in. Okay? It'll be the same size test, same number of questions. All I do is change the numbers.
But all this was 100 points.
No. It was. I just entered as the test category was entered out of 100 because I didn't know what it was going to be. I just entered the category in the grade book because I wanted to make sure it was in there. It's always out of 70s or something like that. So
When does the quarter end? What did you
it's like
say?
a couple weeks.
That's
March
not
16th.
No, it's soon. So
I need to.
What's 65 divided by
I have to take the first day.
I have a big plus in GPA.
90.
What?
I missed a lot.
Okay. All right.
He doesn't affect your GPA.
Hey. All right. Here we go.
That's not the one I did.
Hey. First one. All right. If you multiply by pi over 180, you can simplify the 225 and the 180. It simplifies down to 5 over 4. At some point, you had to simplify if you tried. But the most common thing I was finding, a lot of people forgot negatives. That's where you probably missed a point. Okay. Next. Hey. I'm not going to talk over top of people.
Frosty, quiet down.
Okay, all right, number 2. You have to multiply by pi over 180, 18, and then 180 simplify, you divide by 18 to get pi over 10. 3 and 4, you have to multiply by 180 over pi. The pi's cancel out. Take 3 times 180 divided by 4, you get 135. Then 11 pi over 6, you take times 180 over pi. The pi's cancel, you multiply across. You get 330.
Are you recording this?
Yes. Okay, next. 15, or sorry, negative 150. If you want to get its coterminal, you have to add 360 or subtract 360. I don't care which direction you went. If you added 360 twice, then, or if you subtracted 360 twice, what you had to make sure of is that whatever numbers you get, you had to make sure the negative sign was on there. A lot of people forgot the negative signs. On the next one, you either add or subtract 360. And I'm showing you 4 different answers because I don't know which direction you went. If you added 360 twice, or you subtracted it twice, or if you did one of each, that's what I was trying to get to. Okay? Number 7, you had to use this formula, which was the radius times your angle. The radius on the first one is 80. Your angle was 60 degrees, but you had to convert that. It had to be in radians. And when you actually multiply, you get 80 pi over 3, which simplifies to be 83.78 centimeters. You did have to have a label. Okay, next. 8. Ferris wheel, 12 feet. 12 feet. You rotate 20 times 20 revs. here's the big deal. 20 revs is 20 360s, and then you have to convert it back. That's a lot. That's really big. That is actually 40 pi in radians, and you take that times 12, and you get 1507. That's really big. Because again, you were spinning 20 different times. You're going to travel a long ways. Number 9. This was cosine, this was sine. I kind of warned you they were trig functions. You had to write them down first. And then you had to like flip them over. And then to set up the triangle, cosine is adjacent over hypotenuse, and you're in the 3rd quadrant. And then you figure out the other wall, which is opposite over hypotenuse. And then you can figure out tangent and all that. The big thing I was looking for, negative signs. Did you have your fractions set up correctly? Did you know which one was which? That should have been very straightforward if you were paying attention on those homework days. Moving on. 10 and 11. The co-functions were listed on the board. How you know a co-function, I even stated this on practice test or on test day. How you know a co-function is that it literally has the word co in front of it. Sine and cosine.
Oh, wow.
Tangent, cotangent. That's how you know what a co-function is.
This is some mind-blowing
So,
stuff.
cosecant and secant. So, once you have those labeled, then you just have to take 90 minus whatever the angles. On this one, I convert the angle, which was 25.7, and then you have to take 90 minus that number. And now, if you left it as radians, that's fine, but you better take 2 pi and subtract pi over 7, which would have been complicated. But again, it should have been 64.3. You had to have the co-function, you had to have the angle correct to get both points. Okay, or all the points, I should say. Because some people didn't even attempt these.
Oh, what?
12 and 13, yeah.
What's
12
the
and
worst
13.
mistake you saw on this test?
What?
What was the worst mistake? Like,
Not attempting to do,
Shoot.
what was those later ones, 16, 17? Just skipping them. Like didn't know how to
like
do
the
them.
ones that are worth like all the points?
Yeah, just skip them. Alright, okay, hey, when you take the inverse sine button of this, you get 17. When you take the inverse tangent button, you get 77. You have to make sure of that. 14 and 15, the graph problem, or the picture problems I should say. Opposite over hypotenuse, that's the sine function. So sine of 5 degrees is a over 5,000. You multiply the 5,000 across, you get 435. This should make sense. It's 5 degrees, not very high, but the numbers are
That
big.
truck is about to drive off the cliff.
Yeah.
That's not very good.
Telephone pole, 60 feet. You have the 75 feet. You're finding the angle between them, which is this angle would be adjacent to 60. So you have to use cosine. So cosine is adjacent over hypotenuse. You have to take the inverse cosine button to the other side, and you get 36, 37 degrees, somewhere in that ballpark. I had somebody get that angle very, very wrong.
Like how
Because
far
they
wrong?
I think the most crazy answer I got was I think somebody had 42 degrees, something like that. Which, like, I don't know how it was 42. Like, I
So
don't
it
know.
wasn't
honestly.
something like you look at and like,
Yeah,
oh,
I saw that you rounded or something. I don't know, I don't know where they went wrong. So, because you just had to type in your calculator. So, all right. Anyway, 16, 17. This is in the 4th quadrant. Cosine is adjacent over hypotenuse, and then you have to do the Pythagorean theorem to figure out the missing wall. This is a common mistake. A lot of people were not getting root 8. Got a lot of root 10s. The reason being is that they put the numbers in the wrong spots when you did the Pythagorean theorem. The hypotenuse should be the 3. And then when you subtract across, sine is opposite over hypotenuse. Cosine should be the same number. You should not get that one wrong. And then tangent is opposite over adjacent. Okay. The second problem, 17. The most silly mistake that I saw is somebody got tangent wrong. It was printed.
oh man.
That one you shouldn't get wrong. I can understand getting the other ones wrong, but not tangent.
Man.
So tangent is opposite over adjacent, and those are negatives because you're in the 3rd, and that's why the negatives cancel. But anyways, cosine is adjacent over hypotenuse, sine is opposite over hypotenuse, and then you can go from there. 1819. 1819, you had to find out the one example. You had to convert this angle that was 210, that's in the 3rd quadrant, which 210 is a 30-degree angle in that 3rd quadrant. So you set up your triangle at -1, negative root 3, and a 2. And we're doing cosecant, which is the reciprocal of, the reciprocal of sine. Sine is -1/2. That's opposite over hypotenuse, and then you flip it over. And then tangent is a 45-degree angle, I believe, in the first quadrant, I think. So, and anyway, when you have it 45-degree in the first, tangent is 1/1. Bless you.
Thank you.
There's 1920. 20 and 21, you have to draw the graphs. You have to draw the wave functions. So, the wave is going 2 for an amplitude above and below. The period numbers are affected by 1/2. You can see how I figured it out. And then the +1 is shifting it up. The big thing I was looking for, did you have your 4 hash marks going across? Were they marked correctly? Because when you divide by half, you have to do reciprocal, which that's why it's 4 pi. Did you have your wave go 2 above and 2 below that? And did you have it starting at 1 and going up and down? Okay. There's like little things, like I know some people draw it differently than me, but I'm looking for the basic numbers of what you're getting. The next one, tangent. Tangent's period length is normally pi all the way across, but since you're dividing by a 1/4, which is the same thing like this, so you're dividing by 1/4, you have to flip it over, which is 4 pi. This whole distance is 4 pi, so 2 of it's over here, 2 of it's over here to make the total of 4 pi. Some people are getting that wrong. You're going to hit an amplitude of 2 and -2, and this is what tangent looks like. A lot of people want the other direction, that's cotangent, and it would be shifted from there. Okay, that's your whole test. It's out of what? 70? If you choose to retake, stop in before or after school this week to review the questions you missed, and then set up a time. It has to be done, completed by next Monday. That doesn't mean come in Monday after school, review, and then take it. I'm not going to wait here until 5:30 for you to do that. It has to be done at some point in a reasonable hour. Okay? So that means come in at some point this week, 7:30 till 4 o'clock, something in that range to review, and then set up a time with me where you can take it either during a study hall or something. But it has to be done in a normal hour. I don't want to wait here till 6 o'clock on a Monday. Okay? All right. Again, make sure that if you are not happy with that, come in and retake. Okay? All right. I'm going to collect these back. We're going to take a few notes back. No.
So it's like normal. Hey, don't have that stuff ever
I
again.
wrote 3,
I kind of like her now that you guys all play.
Yeah, she was mean. Dane got finished. Dane was finished with his homework. She made him like read a book. Like her book.
What's wrong with that?
That's weird.
She wouldn't let us talk, Mr.
When was the last time you forcefully made somebody read your favorite book?
Your book, not his book.
No, you can read it. It'll be good for you. You can read it. Yeah, it'll be good for you. I told her that.
Did you see his linebacker drills? No, he like pins it against his nub.
I feel like you didn't want to actually do the homework.
You know what? That one guy who benched so much for prosthetic.
What?
We have homework? Yeah.
That's a lot.
Yeah, we have
for not having a
You-
freaking full on.
Are you taking it back though? The homework.
Today?
I don't
Not
like.
until Wednesday.
Yeah,
You know what
but
I'm saying? Like,
Honestly,
the
quantity. 441.
I knew it.
29.
Probably not.
probably not. You can just like look at the clock and how this
Did you see the David Johnson tape?
He's like,
Yeah, play David Johnson.
like held his wrist up on the.
They play, you play their 40s and 20s.
Hey, the more they talk, the more time I'm not going to give you today to work. So, we're going to take a few notes today. We're going to be going on to the new properties. I'm going to zoom in on this. On your property sheet, we're going to put a new box now. Before we did the box down the middle of that part where it said the cheat sheet, the side without the big unit circles, on this right side, the section we're going into is the sum and difference formulas. These are the 2 that you need to have, or 3 I should say. These are the 3 you need to put a box around today. Okay, these are the ones we're going to be focused on today and tomorrow. These are the ones I introed where it came from on Friday. That was the part of the end of the video that was probably really tough to kind of watch because it was a very tough type of problem to introduce for the first time. What this is used for is if we're trying to do a problem like the sine of, say we're trying to find the sine of 75, like the exact answer without a calculator.
How do you do that?
You have to use the special triangles and these formulas that we have in the box. Okay? So, how it works. If you have your special triangles, 30, 60, 90, 1, root 3, and 2, and the 45, 45, 90 triangle, which does not, definitely not drawn to scale.
That is.
1, 1, root 2, definitely not. All right.
You switched around your triangles.
Anyway.
I was like, oh my gosh, what's going
Hey.
on?
If you're going to try to find the exact answer without a calculator, here's how it works. And I want to show you what the formulas are. Okay, we're going to be using this one. Sorry, get rid of the computer, thanks. Alright.
Oh yeah, go.
Alright.
Or it shows up like the NHS tab.
Okay. Okay. Alright. How this works. This can be done a bunch of different ways. But what I always recommend is you try to use the basic angles that you see here, if possible, to find 75. So I know that we don't have a special formula that has 75 in it, so I can't just rattle off what the sign of 75 is. But I can use the addition or subtraction, which is right here. I can think about two numbers that either add or subtract that are special enough that could make 75. Like for instance, I could go 30 plus 45. Now those angles I'm adding together are special. Those are the special triangles. Those two angles are the angles I'm going to use in my sine formula over here. This is the formula you need to have written. It's not as easy as you think it is. Okay? It's a complex formula, and I showed you where they were derived from last week. That was using the unit circles and using distances. It's really difficult to watch those when they're done for the first time. But how this works, this is going to be my alpha, this is going to be beta in my formula. Okay? And I'm adding the angles together. So this is the formula you need to use for sine. Sine of alpha plus beta. How it works, what the formula is. If you can't read it from your property sheet, it's sine of the first angle, cosine of the second, plus, and these are being multiplied together by the way, plus sine of the second, cosine of the first. So they flip-flop. And I don't care which order it's written, because they're being multiplied anyway. But how this works, you're using the two angles that you split this thing into. So in my case, I'm using 30 and 45, and those are the numbers that are going here. How I always remember this, it's always the two angles, and you're just flip-flopping sine and cosine on each one. And it doesn't matter the order you put them, because you're adding it anyway. Now, the only way this could be different is if they subtract. If they put a subtraction sign here, then you have to have a subtraction over here, and then it will matter which order you put them in. I always just think, since you're doing the sine formula, you better do the sine on the first angle. That's how I start the formula right away. And then you flip-flop. So in my case, I'm doing sine of the 30-degree angle times cosine of the 45 plus sine of 45 cosine 30. So you're just flip-flopping the two angles. Now, how this works, how I find my exact answer, and all the angles look basically the same. You just use your special triangles and you rattle off what these fractions are. Those two are being multiplied together. You're going to rattle off the next two from your special triangles. And you just have to know what SOHCAHTOA stands for, right? So, on the first one, sine of 30. That's, in SOHCAHTOA, that's opposite over hypotenuse. So that's what, 1/2? Yeah. Cosine of 45, that's the adjacent over hypotenuse, so root 2 over 2, which is 1 over root 2. So it's the adjacent wall over hypotenuse for the 45. Sine of 45 is opposite over hypotenuse, so that's root 2 over 2. And cosine of 30 is adjacent over hypotenuse, so it's root 3 over 2. And how do I get to my final answer now? Is you actually multiply these two fractions together, and when you add, they already have common denominators. That's the beauty of doing this. That this is going to turn out to be, this is going to be root 2 over 4, plus, if I multiply these together, that's root 6, and yes, you can multiply radicals together. That's root 6 over 4. And when you add, my final answer, which is in simplest form, this is what I want. I want root 2 plus root 6 all over 4. This is the answer that is the exact digit for what the sine of 75 is. It's not a decimal. I don't need the decimal of it.
I bet you
It's
could
the,
get a decimal.
it's the exact answer for what I'm looking for. This is on the numerator, the 4 is in the
You have to do
denominator.
that?
That's what I'm looking for.
You suppose you could get a decimal?
Yeah, I mean, I could
Let's
guesstimate what
try
the
it
numbers
on a
are.
calculator and see if it comes
So-
up with the same.
No. So the whole point of this is we do this without calculators. Most of this chapter we will not need calculators for. The only time we potentially would need a calculator is if you don't know how to convert angles from like radians to degrees. That would be the only time we'd need a calculator. But most of the time they're going to have you do very exact answers. Now, obviously today was to introduce you to that sine addition formula. Like we haven't seen this before, how you can find random, weird, obscure angles and what's the formula so you can find the exact answer of them. And I'm not going to joke, most of the answers you're going to get in your homework, they all look like that if you're doing sines and cosines. They're all the same because all the angles we're going to use are from the special triangles. So those are the only options you have. Even when we do tangent, we're still going to get numbers that have, you know, 1s and root 3s and 2s and 1s and root 2s in it because we're doing the special triangles. Now, the goal today was to introduce you to the sine formula because I think we did cosine on Friday. I want to do a cosine problem as well, but I want to show you this for the first time, like what we're going into. Now, like Friday, I introduced where this came from, like where it was derived from. It was using distance formulas and stuff, which were really difficult for the first time you ever see it. But the goal is to show you like potential what we can do with this. Even if the numbers don't work out nice and pretty, there's a way that later on that we could potentially find angles that we could do. Okay? All right, questions?
Wait, why is it like plus or minus though?
It's plus or minus because it doesn't matter if you want to add or subtract, so I'll explain. If you wanted to get to 75, there's a couple different ways you could have done it. You could have chose to do different angles to add and subtract to get you to 75. Because maybe the angle is so weird that you have to subtract to get to it instead of adding.
Yeah. How do you pick 30?
Okay, so how do you pick the numbers? If you take your property sheet, now I'm going to use this, I'm going to go to the other side. The angles you're allowed to choose from. So if I zoom out in this property sheet and I go to the other side,
Whoa.
these are the angles you're allowed to pick from. Any of these. So you can use 0 all the way up through 360. It can be any combination of these angles to get the one that's inside the parentheses. So like when I was making the 75, I can do any combination of these to get there. As long as I'm using these angles to do it.
Has to be on that.
Has to be on this graph.
So like 30 and 45.
30 and 45.
How do you pick one plus 30?
You pick any two that either add or subtract to make that number that's right here.
It's not that difficult.
No. As long as that the numbers, when you actually do the math here, it actually makes 75. So if you're subtracting, it will matter the order you put them in. Okay? So, like for instance, to make 75, I think I could have done. What are some weird numbers I could have done? What is it? Can I do? I don't want to do any crazy subtraction. Okay, let's do this. Let's say I want to do 105. This hopefully this will help you out if you're going to figure this out. Hey, does anyone still do this problem?
No.
Okay, let's
How
say
about
we're doing
210 minus 135?
what?
150 minus 45.
210 minus 135.
150 minus 45.
Alright. Hold on.
210 minus 135.
Okay.
150 minus 45.
Cosine of 105. All right. Let's say we're doing this one. Now, just to answer your question there, Mason, how do you know which angles to pick? It doesn't matter as long as you pick two angles that are on this thing that you're either adding or subtracting to make it.
60 and 45.
60 and 45. So maybe you're that person. Maybe you're the person that does this. 60 plus 45 makes 105. Maybe that's just immediately what you thought of. That's fine. This will give you your answer. It'll be the same answer as somebody that chooses two different ones. Maybe the angles you thought of was this. Maybe you thought it was 135 minus 30. Because that angle is here, and you're using 30. Maybe that's what you thought of. It doesn't matter. As long as whatever one you choose you use the formula correctly for whatever one you chose. Like what I mean by this. Let's say I do the 1645 because that was the first ones I heard, right? So if you're gonna do the cosine addition formula, you have to think about what the addition formula is for cosine. Now, this one is different than sines. So if you look at the back of your property sheet, let me go to the back of my property sheet, and I'm gonna zoom in here on cosine. Now this is different. So if you're actually looking over here, the cosine formula for addition and subtraction is right here, and you have to use this one, which is slightly different.
Why is the subtraction on top?
Okay, cosine of addition is doing this. It's cosine of the first angle, cosine of the second angle,
Subtracting.
subtraction, sine of the first, sine of the second. It is the opposite when you do cosine. It's the opposite when you do cosine. It's not like the sine formula where it was plus and plus. How you know that? It's right here. You actually have to look at the top sign and the top sign. That's how they're marked. So it actually tells you which one to pick. That's why the formula sheet does help you. It does tell you if it's a plus or minus sign, which one is it. Now, since Nicole picked this one, the 60 plus 45, this is the formula we have to choose if we pick the 60 and 45. Because she's choosing to add the two numbers together, so this is the formula I have to use. So the 60 would go here, the 45 would go here, or it doesn't matter, like Mace, your question was, can I switch them? Yeah. I could switch the 60 and 45, but you just have to matter where you put them out here then. So it looks like cosine of 60, cosine of 45, subtracting sine of 60, sine of 45. And again, like I said earlier, all these answers are going to look similar. They're going to be the same style of answer. They're not going to be anything different. So let me finish this problem. This will be our last problem of the day. So cosine of 60, if I go to that special triangle which I just erased here, cosine of 60 is root 3 over 2. That's the adjacent to 60. Actually, no, it's 1/2. Sorry, it's 1/2. 1/2. Sorry. Cosine of 45 is root 2 over 2. Sine of 60 is root 3 over 2. And then sine of 45 is root 2 over 2. And the answers all look the same.
It's root 2.
So, root 2 over 4 minus root 6 over 4. And my answer looks almost identical to what we did earlier. I said, all the answers are going to look the same, they're just slightly different. Like in this case, the difference between this problem and the last one we did had a subtraction sign. Some problems will have multiple negative signs, some won't. Some of the answers will be identical because they're actually the same trig function. Now, why we're doing this? We can do this type of math for any weird, obscure angle, as long as that you can figure out the combination of numbers to add and subtract with these.
Can you do a 37-degree angle?
Yeah, technically we could, but we're gonna need later formulas to help us out with that. Like we can do half angles, we can do things like that to get to weird ones like 37.
Yeah, like
We can break it up so it goes like further and further
12?
away.
Okay, we don't have to do that.
We can do really weird stuff, but it takes a lot of math to
What
get
about
these.
like 13.8?
Yes.
0.8?
We can do weird decimals too.
0.8.
But not on this stuff today. The later sections will help us out with
What
that.
about like 3.1415926353?